Okay, the mini lesson today is basic perimeter and area of simple shapes, so not composite shapes. So the first thing we're going to look at is what we need to watch out for. So this is a review of things that you would have done in elementary school, would have done it in grade 9 again, in grade 10, grade 11, some of it, and so now we're back in grade 12, and so this is very basic. Okay, first of all, just so we make everything clear that perimeter is the distance around a two-dimensional shape. Okay, so it's the red that I'm interested in, the distance around. So if I took a string, how much string would it take for me to go around? On the other hand, if I look at area, area is the space inside. So in this case, it's the red space inside the circle, okay, or the rectangle. Now, when we're doing this, a few different steps that we need to make sure that we have, and these are written down already for you. Ensure that all the units are the same. So in other words, not a combination of units. So this could mean some of the units are imperial, some of them are metric, so convert to one or the other. It could be that, for instance, we're in meters and some of the units that they've given us are in centimeters or in kilometers. So we need to make sure everything is in the same units. And obviously, if they're not the same, we need to convert them. The next thing we need to watch out for is obviously we have to identify the shape that we're looking at and find a formula for that shape. And formulas for the shape in most cases will always be given to you because again, it's a concept that you could just Google. So if you can Google it, it's not something that you need to memorize. Also identify the measurements needed. So we have the formula, so we know that we need certain measurements in order to fill into the formula. One thing that you really need to be clear with is dealing with if a formula asks for a height. So if they ask for a height, it's the vertical height that they're talking about. So you need a vertical height. Okay, so that means that it has to be a perpendicular that they've given you the height of. So if we're talking about triangles, if we're talking about rhombuses, rhombi, all of those need the perpendicular height. So sometimes to find some of that information, you may need to use other things. You might need to use the Pythagorean theorem, for instance. That's a really common one to find, to use. Okay, so now let's look at some examples. So for these examples, we want to find the area and perimeter. The first shape that we have is obviously a circle. Okay, there's only one measurement and it's in meters, so I'm fine. So if I go and look at what we were told a minute ago and bring this out, measurements are all the same, yes. Identify the shape and find a formula. So it's a circle, so I need to find the formula for a circle. Now on your sheet, you do have a formula sheet. I'm just going to bring mine up and shrink it back and forth as we need it. So here we go. I can see that when I'm looking at a circle, it is the one on the bottom, and I need the area and the perimeter. So they're at the bottom, so that's what I'm going to take from. Notice the perimeter of a circle is not called a perimeter. They give it a special name called circumference. Okay, and they use the letter C, but it still is the perimeter. So I'm going to bring down the formula sheet down here. And the first thing I'm going to do is I am going to write down my formula. So I'm going to go back up here, get a pen. I'll do it in green. And we start with, let's start first of all with area. Area, according to the formula sheet, was pi r squared. Now in my picture, you can see that the diameter is 6, so that means my radius is going to be 3, so I'm going to have pi times 3 squared. Okay, which is actually 9. Again, punch that into our calculator, we end up with 28.27. And area, we're looking at squared units, so we're going to use meters squared. Okay, next thing we're going to look at is the perimeter. Perimeter, remember I told you, is the same as circumference when we're talking about circle. And there are two formulas. I'm going to use pi d since they gave me the diameter. So that's going to be pi times our 6. Again, we punch that into our calculator and we end up with 18. Hold on a second. 18.85. And this time it's just meters, not meters squared. Okay, so identify our shape, our formula, make sure we have everything we need to substitute into the formula, make sure after our calculations that we have used the units. All right, next shape. All right, our next shape is this one. And not as concerned whether you know the name of that shape, however, we need to find a formula for it. Okay, now it is a trapezoid. You can see it's the second one from the bottom. Okay, same shape as what we have. Notice they have an H, a perpendicular height. We have a perpendicular height, and so we have two formulas. Now, before we write down the formulas, we want to make sure that our units are all in the same measurement. So we have feet, 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 feet. So that is fine. We have a tick, two ticks here. So we know that that means that this side over here is also 6. So we're just going to write that in just so that we remember that. So if we find the area, first of all, okay, we can see what our formula is. It says area is 1/2 a plus b times the height. Right? So it's really important on your formula sheet to compare what they call A and B with your diagram. So in our diagram, A and B are the 11 and the 18. Okay, going to move this out of the way because we don't need it. And let's switch to blue. So we have area equals 1/2 A plus B times the height. Substitute in our values, 1/2, 11 plus 18, multiplied by our perpendicular height with just 5. Then it's just a matter now of doing some calculations. Most of you have a half-decent calculator that you could have gone from this second step here right to your final answer. And if you notice, in most cases, I am giving my answer to 2 decimal places. This one only 1 because that's all I ended up with. And this is feet squared. The next thing I need to do is the perimeter. Now, according to the formula sheet, they tell me that the perimeter is the distance all the way around, and they say A plus B plus C plus D. So we can do that. So our perimeter, so I keep switching tools here, our perimeter equals A plus B plus C plus D. And again, if we put all our numbers in, we have 2 times 6, because there's 2 6s, plus 11 plus 18. And again, it's just a matter of putting that into our calculator. And when we do that, we end up with 41. And it is feet, but not feet squared. And our final question. Now, there is some issue with our final question. One of the measurements that's on your sheet is incorrect. So we're going to first of all correct that. And the measurement that is incorrect is the bottom one where it says 2.8 meters. We're going to change that to 2.4 So that's the very first thing that you need to do is you need to change that to 2.4 meters. Okay, if we go through the steps now, we were told to make sure everything is in the same units. You can see we have a problem with this one. We have centimeters and meters. Now, it doesn't matter which one you convert them to. I think that for me, it's going to be easier to convert this 140 to a smaller number. And if I convert it to meters, it's going to be 1.4 meters. Okay. So first of all, if I look at the formula that I need, and the formula for a triangle for the area is area equals 1/2 base times height. Okay, remember height is the perpendicular height. When I look at my picture, I do not know the perpendicular height. You can see they've drawn it in, but I don't know it. Now what's special about this triangle, it is an isosceles triangle because these two sticks here. Okay, so that does tell me something there. The other thing, however, a property that you maybe aren't aware of, when I drop this perpendicular down to the base, it actually cuts this base directly in half. So half of this is half of 2.4, half of 2.4. Now you know half of 2.4 in from your head would be 1.2 meters. Okay, so now we have everything, all the information on the basic triangle. We need to find this perpendicular height. You can see that when I'm looking at the perpendicular height, I'm just need part of this triangle. I'm going to look at the right angle triangle that's here. Okay, right angle triangle. This is my hypotenuse. Okay, so I know my hypotenuse and I'm finding one of the other sides. So when we look at this type of question, the first thing I need to do is find the height. This h here is the hypotenuse. So I'm writing down the Pythagorean theorem. So I'm finding side height b. So we have 1.4 squared. I know the hypotenuse, so that's why I'm subtracting. And again, if we take our calculator and calculate that, we end up with 0.52. However, that is b squared. I need b, so I need to take the square root of that number. So I end up with 0.72 meters. So now when I'm looking at finding the area according to our formula says area equals 1/2 base times height. So that's going to be 1/2. The base we're going to use is the whole base. So it's not 1.2, it's 2.4. And the perpendicular height, which we found was 0.72. Again, this is a calculator job, and punch it in and out comes 0.86 meters squared. And our perimeter is the distance around, so it's actually taking each side and adding them together. We know that two of the sides are the same, so we actually could use 2 times the 1.4 plus the 2.4, and we end up with actually an even number of 4 meters. Hold on, I think maybe something's not quite right here. I don't think it does equal that. Just hold on a second while I get my eraser. So we end up with 2.8 plus our 2.4, which equals 5.2. Okay, so just watch my calculations sometimes. 5.2, and it is meters. Okay, good luck. You can try some for yourself now.